Didn't record any of that, dang it. There's your proof. Wrapped up. Yep, okay. All right. This is your, yeah. This is your proof from the homework. I'll go back to the rest of them, but this is 28 from 4-2. This is actually the third angles theorem, right? So this is what you were just talking about. Could I use third angles theorem without using the actual third angles theorem? And this is how you would do it. So if they give you that A is congruent to D, B is congruent to E, those are given, and they're already marked. How can I prove that the third are also equal without using the third angles theorem? So now you could go straight to the next step and it would be third angles theorem. But this one you're going to have to go through triangle sum, right?
Yeah, triangle sum.
So A, B, we don't know about that yet, equals 180. D, E, F equals 180. And that's triangle sum theorem. Good. They both equal 180, which means they equal each other. Yep. That's substitution. And then what I'm not showing, the step I'm not showing is to subtract them off, but this is what it would look like. I would have taken the A from this side and the D from this side because I already said they're congruent up there, and the B from this side and the E from this side, and it leaves you with C and F, third angles. Oh no, sorry, subtraction. So now you can go straight from 1 to 4, and your reason would be third angles theorem. You don't need to work that all the way through, okay? You're basically just practicing proofs. No, it would be third angles theorem. So if you went first to the last one, it would be third angles theorem.
No, I'm talking about for the last one. Is it just subtraction or is it subtraction POV?
It's actually subtraction property of congruence, but it's fine. Either one is fine. Yeah. Mm-hmm.
And do you have anything before when you use the third angles theorem, or you just use it whenever?
As long as you know two pairs of one triangle match two pairs of the other, then you can get to third angles. Yeah. Okay, and then there was another proof, and this is 32. Okay, this time it said that WX is perpendicular to VZ, so that's not marked. I would mark it here at point Y. It says that Y is the midpoint, so I've got 1. Y is the midpoint. VW is congruent to X, VW here. And VZ bisects angle WVX. All that's given. Yeah, we know we're proving these triangles congruent. So if you want to jump, if you want to know, you guarantee yourself at least 2 steps. Like if you don't do this, shame, shame, shame. Okay, now I got to get all the spaces in between. Again, I need 3 pairs of angles, 3 pairs of sides. So what do I have based on the given and my diagram right now? How many pairs of what do I have proven already congruent? How many congruence marks do you see on that diagram?
2.
There's 2. I have 1 pair of sides, yes?
Yeah.
I need to get 2 more pairs of sides and all 3 angles, okay? So go with the perpendicular. If it's giving you that those lines are perpendicular, what does that mean? They're both 90 degrees, so I could go through the process of saying they're both 90 degrees, definition of perpendicular angles, and then I could say they both equal to each other, right? Substitution. Or the shortcut is that angle VYW would be congruent to angle VYX because perpendicular lines form congruent adjacent angles. Good. Again, I could have said that they both equal 90 degrees, definition of perpendicular, and then they equal each other, substitution, but now I've done that in 1 step, so I just eliminated a step. Connor.
Is it okay if the second step I did X, Y,
Sure, you could do this in different order.
Well, I said XY is equal to WY and then put definition.
Yeah, so you can do it in a different order. We're eventually going to have to do that anyways, right? So let's add that step. So WY is congruent to YX. Definition of a midpoint. Again, they gave you that there's a midpoint. You're going to need to use it. So now I've got that and that. Now I've got 2 of the 3 sides. How do I get the third pair of sides? This should be the easy one, folks. Third pair of sides. How do I get to the third pair of sides? If you look at that diagram, is there a third pair of sides that's shared? Vy equals Vy, and why is that? Reflexive. We're going to do so much more work on triangles that you want to start to identify the easy stuff like that. As soon as you see something that shares a side, that's a reflexive side. If you see vertical angles, you got vertical angles. If you've got midpoint, you've got midpoint. So start to identify those things. Make it easier for yourself. It's going to be repetitive. That's okay. All right, so now we've got all 3 pairs of sides. We still only have 1 pair of angles. What other information is in my given I haven't used? The bisects. What's it mean to bisect? Cuts it into 2 congruent parts. So if VZ, which is this ray, bisects angle WVX, then it's saying this is congruent to this, or angle WVY is congruent to angle XVY. And that's the definition of an angle bisector. Or bisector is fine. Now, how many pairs of angles do I have? 2. How do I get to the third pair? Third angles theorem. Which I can actually just use W and Y, or W and X, because those don't share a vertex.
So you can just say.
That's the only one you could just use, just the one, yeah. Now I got to I have all 3 pairs of sides, all 3 pairs of angles, so those triangles are congruent. Connor. If there's not another angle that's being shared by that vertex, so there's no other angle that involves X, it's just that one angle, right? If it was split, so like if it had a line in it.
So like V?
So V, exactly. So like if this had another line here, I could no longer use X by itself. Camilla.
So for like number 2, I could have done that.
So you could have done 2 steps here. I could have said VYW equals 90, X VY equals 90, and that's definition of perpendicular lines. And then I could have said VYW equals X VY, and that's substitution. And this is why your proof, I'm going to give you lines on your quiz, but you can go over those lines because sometimes you can do steps in more steps. Does that make sense? And it's not wrong. That's not wrong. That's still right. It's just that we did it in one last step. Lewis.
You have to show that all the lines and angles are congruent.
You have to show 3 pairs of lines and 3 pairs of sides, and then you can go to your proof. So I'm like, that's how the proof will be. Like that, like there's your answer. You have to show it. The difference is how the information is going to be given to you. Is it going to be midpoints? Is it going to be reflexive sides? Is it going to be like that kind of stuff? Yes. Questions on this one? Yep.
What was the definition of angle bisector?
That a ray or a segment or a line that cuts an angle into 2 congruent parts. All right, so your quiz, which is tomorrow, is covering 4.1 to 4.3. Okay, in 4.1 we talked about the triangle sum theorem, which is that all the angles add up to 180. The exterior angle theorem that says that the exterior angle equals the sum of the remote or non-adjacent interior angles. The corollary to the triangle sum theorem said that if you have a right triangle, the 2 acute angles of a right triangle are complementary. So if you have one 90-degree angle, then the other two have to add up to 90. We classified the triangles by the sides, which are scalene, no two sides the same, isosceles, at least two sides the same, and equilateral, all three sides the same. And we classified them by angles. Acute, where they are all less than 90, right, 1 is 90. Obtuse, 1 is larger than 90, and equiangular, where they all are equal.
Wait,
4.2 is the definition of congruent figures, which is all the sides and all the angles are congruent. A congruent statement like A, B, C, triangle A, B, C, is congruent to triangle D, E, F, where the order of the letters is important. A matches D, B matches E, C matches F. Third, angle theorem, which we've now used like 17 times just today alone, which says that if we know two pairs of angles are the same, then the third are congruent. Reflexive, anything equals itself. Symmetric, if A equals B, then B equals C. Intransitive, if A equals B, B equals C, then A equals C. All those properties are within the proofs in that section. And then 4.3 is your rigid transformations. Translations, reflection, rotation. You have a quiz review on Canvas. The answers are there. You are taking the quiz the first part of class tomorrow, so you need to make sure you're ready to go when you come in.